Taking a massive industrial facility to net zero, that's one of the toughest engineering puzzles out there. You're not just fighting complexity and cost, you're literally fighting a fundamental law of physics. So, how on earth do you solve a problem that big? Let's get into it.
Right. So just picture a factory floor for a second. It's a whirlwind of chaotic energy. You got waste heat pouring from one machine while a giant chiller is fighting the sun's heat load on the other side of the building. You've got organic waste that costs a fortune to haul away, making it a pure liability. For a single human engineer, trying to make sense of all this, to bring order to that chaos, it's just an overwhelming task. And that's where the solution we're digging into today comes in, the Joule swarm. Now, this is an autonomous AI team, but let's be clear, this isn't some kind of magic wand. It's a highly structured system, and it's designed to act like a digital nervous system for the whole decarbonization process. Its job is to take all that chaos and turn it into a clear, actionable, engineering-grade plan.
And here's exactly how it organizes that chaos. The swarm is built to mimic a virtual engineering firm. It has 11 specialized AI agents, and they're grouped into 3 core divisions that you see here. And what's really important is that they work in a very precise sequence, just like a real-world project team would, to tackle the problem from every single angle.
Okay, so first up is the team that lives and breathes the laws of thermodynamics and mass balance. Their entire reason for existing is to make absolutely sure that every single recommendation, every idea, is grounded in the hard, cold physical reality of that plant.
The whole process kicks off with the Energy Analyst Agent. You can think of it as the facility's pulse monitor. Its first and most critical job is to hunt for these things: peak load events. See, these short bursts of energy demand are a huge deal. Why? Because they can trigger massive financial penalties from the utility company, and they basically dictate how big and expensive your on-site electrical equipment needs to be.
And it hunts for those peaks with incredible precision, analyzing energy data in 15-minute chunks. Now, that's not just some random number. It's the exact industry-standard resolution a human energy engineer uses to build something called a load duration curve. This curve is everything. It provides the fundamental thermodynamic baseline for every single decision that comes after it. So once that baseline is set, the circular strategy agent jumps in. This agent acts like an industrial ecologist. It's programmed to see waste not as a liability, but as a resource. It analyzes the facility's waste streams for their energy potential, what engineers call their calorific value. So in engineering terms, it's converting a costly problem, an emission source, into a valuable on-site renewable energy asset, like biogas.
And this right here perfectly illustrates the mandatory sequence in any real engineering project. You see, first, you must understand the physical load of the facility. No shortcuts. Second, you map out all the available on-site resources, and that includes waste. Only then, once you have that data, can the market analyst agent step up and accurately design an optimal renewable system, like a solar array, that is perfectly sized to the actual needs and constraints of that specific site.
Okay, so let's see how this all builds into the next phase. Once you have a plan that's physically sound, the second division takes over. Their job? To translate all that hard engineering into a business case that any CFO would be excited to get behind.
This is where the Finance Navigator agent comes in, and it basically acts like a green capitalist. Its whole purpose is to treat renewable assets as financial instruments. It's got complex policies like the U.S. Inflation Reduction Act, hard-coded into its logic, which lets it hunt down every single available incentive. For example, in a case study we're going to look at in a minute, it found a whopping $375,000 tax credit. And that brings us to the most crucial point. This agent's job is to prove that decarbonization isn't just an expense, it's a high-return investment. By crunching the numbers and calculating metrics like the internal rate of return and payback period, it can show, for example, that a project will pay for itself in just 5.5 years. That's how you turn a capital project into a real competitive advantage.
While the finance agent is doing that, the sustainability analyst agent is acting as the environmental accountant, or a metrologist. Its job is to perform what's called a life cycle assessment, which means it converts energy units, like kilowatt hours, into a scientifically defensible carbon footprint, measured in metric tons of CO2 equivalent. It even breaks it down by Scope 1 and Scope 2 emissions, giving you the hard, verifiable data you need for any credible ESG report.
And that brings us to the final division, the governance layer. You can think of this team's purpose as being the digital engineering department's immune system. It's there to make sure every single output is accurate, physically possible, and can survive a tough audit.
This is the most fundamental question in all of engineering, and answering it is the core job of the self-tuner agent. It is the system's built-in quality assurance loop.
Now, this agent is absolutely critical for preventing what people call AI hallucinations. It is constantly running sanity checks against the laws of physics. So if another agent suggests a boiler is over 100% efficient, which, violates the second law of thermodynamics, or that solar panels are magically generating power at night, the self-tuner flags it immediately. Its job is to keep the entire swarm firmly grounded in reality.
But okay, beyond just the physics, the final plan also has to survive legal and regulatory scrutiny. And that is where the greenwashing detector agent comes in. It's designed to act as an internal adversary, constantly challenging the system's own conclusions.
You see, this agent's purpose is to enforce absolute integrity. It scans the final report for any vague marketing fluff like eco-friendly, and it just rejects it. It demands that every qualitative claim is backed up by hard, quantitative, auditable data. This is what makes the final plan not just appealing, but legally and scientifically bulletproof.
So what does it actually look like when this entire digital department works together on a real problem? Well, let's take a look at the results from a simulation that was called Project Phoenix.
The swarm didn't just recommend, slapping some solar panels on the roof and calling it a day. It designed a truly integrated system. As you can see, it took a 4-ton per day waste liability and converted it into an on-site biogas energy source. It designed a solar and battery system specifically to attack the facility's most expensive peak loads. And the end result, a massive compliance headache, was transformed into a high-yield asset with a 5.5-year payback.
And this really shows the final output in black and white. The digital engineering department delivered measurable, auditable value across every critical metric. The plan generates significant operational savings, it creates a substantial and verifiable reduction in the facility's carbon footprint, and it delivers a strong financial return. It's a clear win however you look at it.
So, what we've walked through here is how a swarm of specialized AI agents can function as a tireless, hyper-efficient, and physically grounded engineering team. It's a system designed to bring order to the sheer chaos of industrial decarbonization. And it leaves us with this final thought to chew on. What becomes possible when this level of analytical power is available to everyone instantly?